So today we're going to cover the last section of our solutions in aqueous, or reactions in aqueous solutions unit called classifying reactions. So far we've talked about a couple different types. Double replacement, where we form a precipitate, which is an insoluble solid. We talked about acid-base reactions, where we form water and a salt, and then we also talked about oxidation-reduction reactions, where electrons are transferred. And the types of reactions we're going to talk about next fall within the oxidation-reduction larger category, but then there are several types within that category. One of the first types is a single replacement reaction. So if you think about double replacement reactions, and if you feel like you need a review, you can always rewatch section 1. In double replacement, both cations and anions switched partners, basically. Well, in single replacement, based on the name, only one cation is going to switch places, not both. And so only one type of anion is exchanged. So only, electrons are still transferred, but it's not a double replacement. So for example, if we have something like copper on its own and zinc oxide, well, the copper and the zinc are going to trade places. So it's a single replacement because there's no other anion to trade places with. Hence, only one type of anion is exchanged. And so we get the copper going with the oxygen and then zinc by itself. And so we've singly replaced the cation. Okay, let's look at something like aluminum and calcium oxide. It's the same idea, and these are very easy to recognize because you have this lone metal all by itself. So here the aluminum and the calcium are going to exchange places. Aluminum is going to go with oxygen, and then we have calcium by itself. Now we don't need to worry about the calcium, it's on its own, but this aluminum oxide, we do need to make sure that it's written neutrally, and all the positives equal all the negatives. Well, we know that aluminum forms the anion Al3+, and oxygen forms the, aluminum's a cation, oxygen's the anion, forms an anion of 2-, so we need 2 aluminums and 3 oxygens to make it neutral. But it's still a single replacement, even though, we have more than one aluminum and more than one oxygen, it's still the exchange of the cations, and so this still qualifies as a single replacement. So don't let the subscripts fool you. These are just there to make the compound neutral. And so single replacements tend to follow the general form A plus BC goes to AC plus B. Now, can B go first and then AC come second? Absolutely. You don't have to have your single element by itself first and then the compound. They can switch orders, but those two species should be present as reactants, and then AC and B present as products. Remember, cation always goes first, and A and B are our cations. Okay, another type is a combustion reaction. When you combust something, you usually burn it. Okay, and so this always involves oxygen as one of your reactants, and usually a carbon-based substance, so anything organic. Logs are organic. We know wood and logs burn very well. Anything with carbon and hydrogen usually, and sometimes oxygen as well. And the two products are always going to be carbon dioxide and water. So again, this one is pretty easy to identify because you always have oxygen and some carbon-based substance as your reactants, and you know carbon dioxide and water are always going to be your products. So for example, we have CH3OH plus O2. Well, I know that I'm going to form CO2 and water, and I just need to make sure it's balanced. And so if I put a 2 here, that gives me 4 hydrogens, which matches with my 4 hydrogens in my CH3OH, but now I have 3 oxygens. So because I have 4 total oxygens on the product side, I need this value to equal 3 so that I can add it with the 1. So if I multiply it by 3 halves, that gets it equal to 3, but I can't have this 2 on the bottom, so I multiply everything through by 2, which makes that 2, which makes that 3, which makes this 2, and makes this one 4. Okay, so the balancing for combustion reactions can be a bit more tricky, but as long as you recognize the reactants are carbon-based compound oxygen and CO2 and water. Now, are they always a carbon-based compound? No, because other things can burn, but for our purposes, this is the general form. Oxygen will always be one of your reactants, however. So in general, we have CXHY, X and Y representing subscripts of some organic compound, plus oxygen gas is always a reactant, and we're always producing CO2 and water. Okay, another type of reaction is a synthesis reaction. If you synthesize something, you form it. And so this is a single compound formed from simpler materials, usually the elements that make up that compound. And so, for example, if we have the elements hydrogen and oxygen, that forms water. And we can also go through and balance it. And so this should be easy to identify because you've always got one product and more than one reactant. You could have 3 reactants or however many, but it's all going together to form one product. And so it follows the general form A plus B goes to AB. Okay, then we have the opposite of synthesis reactions, which are decomposition reactions. If something decomposes, it breaks apart. Roadkill decomposes on the road, and pretty soon it's not a raccoon anymore. It's tire tracks. So that's what you're thinking of when you think of decomposition. Basically, we're taking a compound and breaking it down into simpler compounds or component elements, and this is usually done through heating or passing electric current through something. It's kind of hard to break things apart. And again, it's the opposite of a synthesis reaction. So if we have H2O, we're just going to go the opposite direction, H2 plus O2, and this happens through electricity. In fact, there's some app on your cell phone, that alchemy game. If you put like hydrogen with oxygen and electricity, it will form water. It's kind of cool. So there is some actual chemistry in that game, but not everything is chemistry in that game. So decomposition reactions will follow the form, in general, AB goes to A plus B. And like I said, you could have more than one product in this case. Okay, so let's take a look at an example, and number 1, predict the products, and 2, identify the type of reaction. Okay, so we have 2 elements by themselves, so I'm thinking that this is going to be a synthesis reaction because potassium and chlorine will go together, and they are in their elemental forms right now. Potassium is a 1+, chlorine is a 1-, and so that is a neutral compound the way it's written, and then we just need to balance it. And so that is a synthesis reaction. We're taking 2 elements, forming one product. Okay, let's see, we have iron, 3 oxide, and aluminum. I see a metal by itself, and then a metal bonded with an anion. And so to me, this looks like single replacement. And so I'm going to replace the the iron with the aluminum. So now I have aluminum, and aluminum's a 3+, oxygen's a 2-, so Al2O3, plus iron on its own. Okay, and that's a single replacement. We replaced the cations. Only one anion was present. Okay, so here we have just one compound by itself. So right away, I know that this is decomposition because the only thing it can do is break apart. That's it. So we have magnesium and probably oxygen gas. And then it looks like we need a 2 here to make that balanced. Okay, so here we have an acid, and I know that because of the hydrogen in front. And here we have a base because of this hydroxide. So right away, I know that this is an acid-base reaction. And I know that the products of an acid-base are always water. And you can write water as HOH or H2O. And my other product I know is I need my cation first, which would be my sodium. And then the anion is my nitrate. And because they're 1+ and 1-, that is a neutral compound. And so I think I'm even balanced. That looks all set. Okay, so let's take a look at this one. We have potassium bromide and silver 1 nitrate. So I have an ionic compound and an ionic compound. To me, it looks like they're both going to switch places. So this is double replacement. So my potassium goes with the nitrate. And the silver, which here is a 1+ because this is a 1-, so remember charges carry. And this was in section 1 if you feel like you need a review. And bromine is a 1-. And so then from here we could decide which one was insoluble and soluble, and even go on to write complete ionic and net ionic from this type. I know this one's aqueous for sure. Okay, so let's try one more. Alright, so here I gave you the products, and so sometimes you'll have to predict products, sometimes they will be given to you. So again, we have one single reactant going to more than one product, and so this tells me that that is a decomposition because it's one single reactant breaking apart, usually into its elements. Okay, so what I'd like you to try is Predict the products. Remember, use all the information we talked about for all the how to identify the different types. I think, like I did in the example, it's easier to identify the type first, and then it makes predicting the products much easier. Okay, make sure you check your charges, and then we'll check these answers in class. Have a good day.